Alright, very good morning. Today we're going to start with chapter 1 Inequalities. Alright, in inequalities, okay, like equal, we have this notation. In equal, if we have this notation, then for inequality, there are four kind of notation. Okay, one is greater than, one is less than, greater than and equal, less than and equal. Okay, so just to remember this, we put a line here, it becomes big. So greater than, we put a line here, it becomes s, small, less than, something like that. Okay, you can remember whichever way you want. So if I put x greater than y, means x is bigger than y. This is how we pronounce x less than y. X greater than or equal to y, x less than. So we can have a look at this. So in this topic here, first topic, what type of inequality we're going to go through? We're going to go through the fraction, rational fraction, rational function or rational function like this, and this is called sandwich type of inequality. Sandwich type of inequality. This is absolute value inequality and this is quadratic. Okay, rational, sandwich, absolute, quadratic, something like this. There's also linear type of inequality. Later we'll go through that. Okay, this is some exercise for you. The answer is given there. Okay, the sum of the numbers of 5. Okay, we have written in words, so how to change it to mathematical terms? This is the way you can read yourself. You can go through this. Each inequalities can be normally inequalities be denoted like this. We denote like this. Okay, we can also denote in terms of intervals. I mean, in terms of bracket like this. Okay, there's no equal means you put a normal bracket. If there's an equal means you put a square bracket. Okay, that's how it goes. You can see the number line also. If there's no equal, there's a circle. If there's an equal, then you shade inside the circle. Okay, quite easy. Now this is a theorem, but this one I suppose many of you know this. Let's say let's say you have 3x less than 6. If 3x equal to 6, how to solve this? X equal to -2. If 3x less than 6, it's almost, yes, you are right, you can bring this -3 here, but but whenever you divide or multiply by negative number, you change the direction. Okay, then x greater than -2. In other words, I'll make sure that the sign on my variable is always positive. So whenever you change the direction, the signs are changing. So I want this positive, so I change my direction. This one become positive, this one become negative. Now for positive number, you can no need to change the direction, just simply can do like this. Okay, that's what the theorem tells. Now let us move on to solving inequalities. First inequality, the type of inequality we're going to see is linear inequalities. Linear inequalities is exactly same how you how you solve any equations. Okay, so in this case you bring the variable to your left hand side. So that's how you get. You can leave the answer like this, or you can use the notation. Okay, if you put a number line here, This is how you draw all the way going greater than 5. Greater than 5 means we put 5 here. If there's no number here, we just put an infinity here, a big number. The second type of inequality we're going to see is sandwich type. Here I'm going to show you two methods to solve this. Whichever method is convenient for you, you can follow. This one multiply here, you get negative 8, 40. Bring the number there. We don't want negative here, so change the sign. But for sandwich type of inequality, the sign is always like this or like this. It is always left to right to left. It doesn't go like this. So this one doesn't go like this. So change back. And cancel this, and then you divide by 3, you get negative 11, 5. So this is one way of solving sandwich type of inequality. Okay. Another way, this is alternative 1. There's another way to solve this. We go for alternative 2. We're going to consider this as first inequality. First inequality, solve this. You get one equation here, one solution. There's another equation here. You split the inequality 2. For inequality 2, that is 7 3 minus 3x, 4. Negative 11, there's another one. So now what you do, you intersect, you don't draw the number line. Put 11 here, 5 here. You have 3 partition. For this one, you draw the number line like this. for this one, this is not just a circle. Draw the number line like this. And then you see where is the intersection. The intersection happened here, so the answer must be in between this. So x is in between -5 and -11 and 5. Alternative 2 might be a little bit lengthier, but it is a very powerful method to solve any kind of inequalities. Okay, so you learn both, practice both. I have the answer is here also, you can see. Okay, now next type of inequality is quadratic inequalities. Here there's also two methods I can show you here. Okay, first method is graphical method, alternative one, graphical alternative. If you find the root for this one, or you want to factorize, you can use your calculator, you can factorize, up to you. So the root for this one is -2 and 3. Okay, so if I want to draw this quadratic equation, remember, just to recall all these things, it's ax square plus bx plus c. Whenever a is greater than 0, it's a smiley graph. A is less than 0, is a sad graph. So here the a is 1 here. Remember, 1 is greater than 0, is a smiley graph. So you draw like this. So -2 is here, 3 is here. This is the x-axis. Okay, it cuts the x-axis like that. And then you see this part here, less than 0. Less than 0 means you take below x-axis, which is this part. So the answer is in between -2 and 3. Okay. This is alternative 1. For alternative 2, we go number line, like the one we did just now here, but a little bit different. Okay. For alternative 2, we factorize this. Okay, and then take one factor, always make greater than 0. Even though it's here less than 0, this is nothing to do with this one. Always make greater than 0. If there's an equal here, then you put an equal here. If there's no equal here, don't put. But this is always greater than 0. Make it always, practice yourself, always greater than 0. Don't follow this one. Okay, no matter this is less or greater, you always put a greater here. This is greater than 3. So now we draw a number line. Okay, we draw a number line whereby put -2 here, 3 here. Three partition. Okay, now For the first, this one, you put a circle, go all the way here, and for the second one, you put a circle, go all the way here. Okay, now whenever you see a line here in this partition, there's a line, you put a plus. Whenever you see a line, you put a plus. Here there's no line, but this one got line, this one both also no line. Plus plus multiply become plus, minus plus become minus, minus minus become minus, sorry, plus. V1 less than, okay, less than, negative, choose negative in between. So the answer is, that is the answer. Okay, this is the number line system. This is another way of solving quadratic. Whichever you feel okay, you can, you convenient, you can follow. Okay. So this one, there is another one. If I want to go through first alternative, smiley graph, greater than 0, look up, x is so equal, there's a equal, so I put a equal here, so x is greater or equal to 3. That is the answer. Alternative, we have this, we already factorize here, this one I'm going to write it here. So we factorize already. Once you factorize, you take one factor. Yeah, I'm going to write here. Take one factor, greater or equal to 0. If there's a equal, you put a equal to 0. Okay, as I told you, always greater, always greater. there's a number, put a plus, plus, minus, plus, minus, minus. Plus, minus, plus, and V1 positive. Positive, you choose positive, which is x less or equal to negative 1 over 2, or x greater or equal to 3. The same answer you will get. Now next one is rational function. Okay, rational function. For rational function we are going to use number line system. For rational function, if this is equation, how we are going to solve this? Because this is equal means we cross multiply and we try to solve from here onwards. But for inequalities, whenever the denominator is variable, if number, no problem. If variable, the x is inside the denominator, we cannot cross multiply. Cannot. So how are we going to solve this? We have to bring everything to the left hand side and make it one fraction now. Okay. So this is the solution. Now we have, you can see here we have 3 factors, 1, 2, 3. I'm going to take the 3 factors here, do the number line system. 2x, remember why I put greater here, that is formula, follow for a while. When follow for the time being, if you have any extra time, then I explain to you why we have to always put a greater here. But this greater or equal to 0, as I told you before, again and again I'm reminding, nothing to do with this one. Even this is less or equal to 0, still I am putting greater or equal to 0. Okay. Okay, now we put a 1 plus minus plus minus minus plus minus 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 minus. Okay, so if you put this one plus, so going to be minus plus minus v1 positive. So we want this one. So the answer is oh, I did a mistake here. Sorry. This is 3.5. This is 2. Sorry, there's a typo. This is the answer. Okay. Now x is in between negative 1 to or x greater than. Suppose I should put a equal here. Okay, there should be a equal here also. Okay. Suppose I need to put a equal because this one has a equal. Okay. But the answer I need to remove the equal because why? See, once you have the solution, you have to make sure this one is not 0 with the solution. So when this one is not equal to 0, you can see here, this one we don't want equal to 0. Any fraction, the denominator when gets 0, everything goes infinity. Yeah? So in this case, we don't want x cannot be negative 1. X cannot equal to negative 1. So I don't want this to be equal. Same goes here, this one now. X cannot be equal to 0. So x minus 2 cannot be equal to 0. X cannot be equal to 2. So x cannot equal to 2. I don't want to put the 2 here. Just put. We have to make sure our solution doesn't contain the value which makes the denominator 0. This one no problem. Okay, only for this one. Let me do one more exercise for rational function, which is not here. Let's say the function is like this, a rational function. What to do? bring this one to the left, make it one fraction. I don't want negative here, just change the sign. Okay, once you get the factorized factor form, this is negative, so you choose negative here. So here we will write x or x in between. 2 and 4. That is the answer. And double check that now we do want what value we do want. You can see here we do want this x cannot be equal to 0, so we do want x to be 2. X minus 2 cannot be 0, so we don't want x to be 2. You can see here this is, there's no equal here, so this is okay, this is also okay, so you can leave the answer like this. Let's say let's say for example, let's say the denominator now, let's say for example is 3 here. Okay, so we don't want this 3 and this one we don't want 3, isn't it? And let's say you get this answer now. You can see that 3 is inside here, isn't it? So how to split this? How do we remove? How are we going to remove the 3 here? It's like this. This number line now is from here to here, isn't it? This number line, this one like this. Now if I want to remove the 3, which means I will take all the points until 3, but I don't take 3, and then from 3 to 4. So we're going to split this. Okay, let's say you have this answer and this denominator. Of course this question we don't have, no problem, but let's say you have it. How are you going to split this? You take x up to 3, but don't put a equal here, or this is how you split. You split here in the 3. Okay, you split. You split this. One is then we remove the 3 already inside. That's how we adjust our solution. Alright, that is regarding rational function. And there's one more here. There's one more which is absolute value. Absolute value inequalities. For absolute value inequalities, I will cover in our next video. So for this class, this recording only up to rational function inequalities. So that's all for today. I'll see you all in our next class then. Take care.